Welcome again, students. So we were on this slide when I stopped the last lecture because I was out of time. And we'll start right here. This formula looks a little intimidating. So we square a bunch of things and add them up and divide by n minus 1. Then in the end we take the square root. Seems like a funny thing to do on the surface. And the reason why we do it is embedded deep in the heart of statistical theory. So I won't go into that now, but I will tell you that the standard deviation, as shown here, as calculated here, has a very useful interpretation. The good news is that this calculation is built into all major statistical packages, all spreadsheet packages, and just about every other package that deals with data will calculate this. So you very seldom need to go through the formula for this. However, I always recommend people do it one time, and I'm going to show you where I would recommend you do that during this presentation. So we're looking at the Austin data about gasoline prices, regular gasoline, 10 different gas stations, and you might remember this data. The mean was 3.02, $3.02, and that was the prices. If we go through the calculation of the mean and standard deviation of this data, you all know how the mean is calculated. You add up the data and divide by the number of observations, 10 in this case. In that case, we got a number $3.02. So we're going to show on a spreadsheet-like calculation what this calculation would look like. So the data is shown on the left, going to 319, and the last observation being $2.97. And in each case, we calculate the deviation from the mean. You will notice that the ones you expect half the data to be above the mean and half the data to be below the mean, and they are the ones that are below the mean. You get a negative value when you calculate x minus x bar, and for the ones that are above the mean, you get a positive value. All right. Then you square those, so all the numbers in the middle column are squared over on the right column, and those are the squared deviations from the mean. Over on the far right, then we add up all these squared deviations, and we divide by n minus 1, which is 9 in this case, and that gives us the standard deviation, and all of that, and then we take the square root of all of that. By the way, the square of that number is something called the variance, and then you take the number before you take the square root is called the variance, and you take the square root and it's called the standard deviation, and in this case it turns out to be 0.0855. That might be slightly different than what you would see in your summary in StatCrunch, because we rounded the mean 3.02. It had more decimals than that. When StatCrunch does this calculation, it will use the actual mean rather than a rounded mean. But for simplicity's sake, we use the rounded value here to show how this calculation would work. So when all is said and done, remember we said it was about 0.85 and we would round it to 9 cents in our previous example. That's what we got here, and this shows the calculations that you would go through. Now, you're not going to have to memorize that formula. What you need to know is its interpretation, and we'll be talking about that as we go forward here. But I always say that everyone should do this calculation once in their lifetime by hand, but not on a difficult data set. So I'm going to invite you to pause the video and take these 5 data points and see if you can calculate the mean and the standard deviation of those 5 data points. And just do it by hand. It shouldn't take you more than about 5 minutes to do that, but that would give you a little more confidence in your ability to calculate the mean and the standard deviation. You can pause right now. It's a good time to pause, but I'm going to go forward and show you the answers. So if you did the calculations, what you should have gotten is that the mean is equal to the sum of the data, which equals 20, divided by 5, the number of observations. So the mean would be 4. Shown on the first slide, the first line there. Second line shows the variance, which is what we get before we take the standard deviation. So the variance is 1 minus 4 squared plus 3 minus 4 squared plus 3 minus 4 squared plus 6 minus 4 squared So 7 minus 4 squared. We take all of those squared values and we add them up, divide by n minus 1, so that's 24 divided by 4, which gives us an answer of 6. That would be the variance. And the final step in getting the standard deviation would be to take the square root of that number. So the square root of 6, if you put it in your calculator, would be 2.45. So all of this could be done with the pretty easily on paper without a calculator, except for the square root at the end. I use my calculator to get that one. The rest of it is pretty easy to do. So if you got those numbers, congratulate yourself. If you did, you might look at what you did wrong or what you did differently than this and see if you can learn from that. That's the calculations. Again, StatCrunch will do all this work for you, but it's a good idea to understand what it is doing. So from that, we learned that the gasoline average was $3.02. The standard deviation was around 9 cents when we rounded it. So at most of these gas stations, the price of a gallon of gas is within 9 cents to $3.02. Most usually means more than half. The majority of the data would fall in that range. All right. So variance, just a reminder, the variance is the standard deviation squared. It's an intermediate step in calculating the standard deviation. It's not useful by itself as a measure of spread. It's in square units. But we'll find it useful later on in this course. We'll learn about that when we get to something called analysis of variance, which sounds like you use the name variance. But you see down at the bottom, the mean 3.024. This was done in StatCrunch, and the standard deviation to 0.085. That variance is there. It's not very useful, but it was an intermediate step, right? If that square root of that variance would give you the standard deviation. We will not worry about the standard error right now. And the other numbers, in the median we understand, and the range, the min and the max, I think we understand. Q1 and Q3 we will talk about later. So I'm going to stop right there. That's really the end of section 1.1, and we will move on to, 3.1. I apologize. And we'll move on to 3.2.